Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 26 video on the chapter of mensuration, where I will solve all the problems of exercise 20F which are based on perimeter or circumference and area of circle. If you have not watched the previous videos on this chapter of mensuration, then I strongly suggest and request that you also please watch them so that you have the continuity of your study on the chapter of mensuration. So this video is part of the playlist CBSE Maths for Class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 26 video on the chapter of mensuration, where I will solve the problems of exercise 20F which are based on perimeter and area of a circle. Okay, so I have written down all the questions on the left hand side, and on the right hand side I will solve the problems. So question number 1 says that find the area of a circle whose radius is. So there are two parts. In the first part, the radius r, small r, is given to be 21 centimeter, and we have to find the area. So we know the area of a circle is pi r square. Now for pi, since in this problem it is not mentioned what value to take, we should consider the value of pi as 22 by 7. So pi is 22 by 7 multiplied by r is given as 21. So 21 square, this much centimeter square. This is equal to 22 by 7 multiplied by 21 multiplied by 21, this much centimeter square. 7 cancels 21 with 3. So this is 63 multiplied by 22, this much centimeter square, and which is equal to 126, and 126 is 1386. So this is 1386 centimeter square. So part 1, the area is 1386 centimeter square. Okay. Part 2, the radius is given to be, r is given to be 3.5 meter. So this implies a will be equal to pi r square, which will be equal to 22 by 7 multiplied by 3.5 square, this much meter square. This is equal to 22 by 7 multiplied by 3.5 multiplied by 3.5, this much meter square. This is equal to 7 will cancel 3.5 with 0.5, and okay, and 22 multiplied by 0.5 is 11, and we have 11 multiplied by 3.5, this much meter square, which is equal to 35 multiplied by 11 is 385. So we have decimal point. So this is 338.5 meter square. Okay. Let's see the next problem, question number 2. Find the area of a circle whose diameter is. Okay, so this time the diameter is given. Part 1. Now remember that so d is given to be 28 centimeter. Now we know area is equal to pi r square. In terms of diameter, this will be r. R, we know twice r is equal to d, diameter. So this implies r is equal to d by 2. So this implies r square will be equal to d square by 4. So the area in terms of diameter is pi d square by 4. So now we have to simplify, we have to put the value. So 1 by 4 multiplied by pi is 22 by 7 and d is 28. So 28 multiplied by 28, this much centimeter square. So this is equal to 4 cancels 28 with 7, 7 cancels out. So this is 22 multiplied by 28 centimeter square, and this is equal to 28 multiplied by 22, 56, so 616 centimeter square. Okay. Part 2. For part 2, the diameter is given as 1.4 meter. So we know that area is equal to pi d square by 4. So this will be equal to 1 by 4 multiplied by pi, which is 22 by 7 multiplied by d square. D square is 1.4 multiplied by 1.4, this much meter square. This is equal to okay, 7 will divide 1.4 with 0.2 and okay, 28. Okay, and so this is 22 multiplied by 2. Let's convert the decimal into fraction. So okay, so we have 1 by 4 multiplied by 22 multiplied by 0.2 is 2 by 10 multiplied by 1.44 is 14 by 10, this much meter square. So this is equal to this cancels with 7, and we have 154 by 100 meter square, which is equal to 1.54 meter square. Okay, let's see the next problem, question number 3. The circumference of a circle is 264 centimeter. Find its area. Okay, so circumference we know is equal to find its area. Okay, circumference is equal to 2 pi r, and we have, so this implies that r is equal to c by 2 pi. C is given in this problem. C is given to be 264 centimeter. Okay, so now what will be the area? Area is pi r square, which is equal to pi r square will be c by 2 pi whole square. This is equal to pi c square divided by 4 pi square, and this is equal to c square by 4 pi. Okay, c square by 4 pi. So if you are given, so if you know the circumference, then based on the circumference you also can find the area, which is equal to, so an area of a circle is equal to circumference square divided by 4 pi. This is also a good formula or result you must remember. So finding the area in terms of circumference, so area is equal to circumference square divided by 4 pi. Okay, so now we know the circumference, it is 264. So 264 square is 264 multiplied by 264. We have divided by 4 multiplied by pi is 22 by 7. This much centimeter square. This is equal to 264 multiplied by 264 multiplied by 7 divided by 4 multiplied by 22. This much centimeter square. Okay, 22 will divide 264 with 12, and 4 divides 12 with 3. Okay, okay, so this is now 21 multiplied by 264 centimeter square, which is equal to, I will use calculator for doing the calculation to save time, but you must do the calculation by hand. 264 multiplied by 21 is 5544. So this is 5544 centimeter square is the area of the circle. Okay, let's see question number 4. Question number 4 says that the circumference of a circle is 35.2 centimeter. Find its area. Okay, so we know that area is equal to c square by 4 pi. We just derived this formula that area is c square by 4 pi. Okay, so circumference is given to be 35.2 centimeter. So this is 35.2 multiplied by 35.2 divided by 4 multiplied by 22 by 7. This much centimeter square. Okay, so this is equal to 35.2 multiplied by 35.2 multiplied by 7 divided by 4 multiplied by 22. Okay, this is equal to, let's convert the decimal to fraction. This will be divided by 4 multiplied by 22 multiplied by 100. Okay, so 132. Okay, 22 divides 352 with 16. 132 16. Okay, and 4 divides 16 with 4. So this is equal to 28 multiplied by 352 divided by 100. This much centimeter square. So how much is 352? 352 multiplied by 28, it is 9856. So 9856 by 100 centimeter square. This is equal to 98.56 centimeter square. Okay, let's see the next problem. Question number 5. The area of a circle is 616 centimeter square. Find its circumference. So we know that the formula that relates area and circumference is area is equal to c square by 4 pi. Okay, so this time area is given and we have to find we have to find the circumference. So this implies c square is equal to 4 pi into a, where capital A is the area. Okay, so this implies this is 4 multiplied by 22 by 7 and the area is given to be 616. Remember, the unit of centimeter square will be, the unit of circumference square will be centimeter square. Since in this problem the area is given as centimeter square, so obviously the radius will be in centimeter. So the unit of circumference square will be also centimeter square. Okay, so now let's see. So 7 will cancel, 6 1 divide, 7 will divide 616 with 8, 56 and 8. Okay, so we have 4 multiplied by okay, so 4 multiplied by 22 multiplied by 88 centimeter square. So this implies C will be square root of 4 multiplied by 22 multiplied by 88, this much centimeter, which is equal to 4 multiplied by 22 is 2 into 11 and 88 is 8 into 11, this much centimeter. Okay, this is equal to square root of we have 11 square, and then we have 8 square, this much centimeter. So this is equal to 11 into 8 centimeter, which is equal to 88 centimeter. So the circumference is 88 centimeter. So this is an important formula you must remember, that relates circumference and the area of a circle. Okay, let's do question number 6. The area of a circle is 1386 meters square. Find its circumference. So we know that area is equal to c square by 4 pi, where capital C is the circumference. So this implies, so basically c is nothing but square root of 4 pi a. Okay. This will be equal to 4 multiplied by 22 by 7, and area is given to be 1386 meter square. So the circumference will be meter. So this is equal to 4. Okay, so let's try to simplify. So 7 will divide 1386 with 1, and then 668, 9, 63 and 8. So this becomes 4 multiplied by 22 multiplied by 198 meter. This is equal to let's see, 4 multiplied by 2 multiplied by 11, and 198 I guess is 22 multiplied by 9. Okay, so let's okay, so this is 4 multiplied by 22 square multiplied by 9 meter. This is equal to nothing but 2 multiplied by 22 multiplied by 3 meter, and which is 132 meter. So the circumference is 132 meter. Okay, let's do the next problem, question number 7. The ratio of the radii of two circles is 4:5. Find the ratio of their areas. So the ratio of the radius of two circles is given to be 4:5. So let's consider R1 and R2 be the radius of the two circles. So area A1, let's say A1 be the area of the first circle, which is having an area radius R1. So A1 is equal to pi R1 square, and we will have A2 be the area of the second circle having a radius of R2. So A2 will be pi R2 square. So the problem is asking find the ratio of their areas. So this implies we have to find A1 by A2. A1 by A2 will be equal to pi R1 square divided by pi R2 square. Pi will cancel out. So this is equal to R1 square by R2 square, which is again equal to R1 by R2 whole square. Now R1 by R2 is given in the problem as 4 by 5. So this is 4 by 5 square, and this is again equal to 4 square by 5 square, which is 16 by 25. So this implies the ratio of the areas, the ratio of the area of the two circles A1 is to A2 will be equal to 16 is to 25. Okay, let's see the next problem, question number 8. A horse is tied to a pole in a park with a string 21 meter long. Find the area over which the horse can graze. Okay, so if this, let's say this be the pole and this is the string, string, let's say this be the horse. Let's say this be the horse, and this is the pole, and so this string, the length of the string is given to be 21 meter. Now the area, the maximum area that the horse can graze is nothing but the circle formed if you consider the point at which the pole is, the point of the foot of the pole, if you consider this as the point O, this will be the center. And if you consider the string, let's say OA is the string, A is the horse, let's say A is the horse, so OA is the string. So the maximum area the horse can graze will be the area of the circle whose radius is OA and whose center will be O. So basically this kind of circle it will form. Sorry for a bad drawing, but anyway, so this is the so the area, the area, the region that the maximum region that the horse can graze is nothing but a circle whose center will be the foot of the pole at which the point on the ground where the pole is where the pole is standing, and the length of the string, you can consider the string to be the radius of the circle. So the maximum area that the horse can graze will be pi r square, the area of the circle, and pi is 22 by 7, and the r is nothing but the length of the string. So this is 21 multiplied by 21, this much meter square, and this is equal to 3. So 66 multiplied by 21 meter square, and which is equal to 6, 12, 1, 2, 6. So this is 1386 meter square. So 1386 meter square. I think I have copied the question incorrectly. The answer is given as 1386 centimeter square, and the length of the string is given as 21 meter. So maybe the length of the string is given as 21 centimeter. I might have copied incorrectly. So let's consider the length of the string to be 21 centimeter. So the area will be this much centimeter square. Okay. So the concept is the maximum area, the maximum region, maximum region that the horse can graze is nothing but a circle whose radius will be the length of the string, and the center will be the point on the ground where the pole is standing. Okay. Let's see question number 9. A steel wire, when bent in the form of a square, encloses an area of 121 centimeter square. The same wire is bent in the form of a circle. Find the area of the circle. So the concept is nothing but, so initially the steel wire was in the shape of a square. Let's say this is a square, and then it was rebent to form a circle. Let's say the area, the radius of the circle is r. So we know it is given that a steel wire, when bent in the form of a square, encloses an area of 121 centimeter square. So let's say, so the concept is that the perimeter of the square will be equal to the perimeter of the circle, because the length of the wire is constant. When the wire is bent in the form of a square, we can the area of the whose area is given, we can easily find the side length of the square, and from the side length we can find the perimeter of the square, which will be the length of the wire, which will also be the circumference of the circle. So we can, from circumference, we can easily find the area. Okay. So let's say so we know that if let's say if each side, the length of each side of the square is x centimeter, then we will have area of a square of side length x centimeter will be x square. So x square should be equal to 121. So this implies x is equal to square root of 121, which is equal to 11. So this implies perimeter. Perimeter of square is equal to length of wire will be equal to 4x centimeter, which will be equal to 44 centimeter. meter. So the length of the wire is equal to 44 centimeter. Now this length of the wire will also be the perimeter, will also be the circumference of the circle. Okay. So now we have to find the area of the circle. We know the circumference of the circle, so we now need to find the area. We know that area of a circle in terms of circumference is c square by 4 pi, and circumference we know will be equal to, circumference of the circle will be equal to the perimeter of the square or the length of the wire, which is 44 centimeter. So this will be 44 multiplied by 44 divided by 4 multiplied by 22 by 7, this much centimeter square. This is equal to 44 multiplied by 44 multiplied by 7 divided by 4 multiplied by 22, this much centimeter square. Okay, 22 divides 44 with 22, so this should be equal to 154 centimeter square. So the area of the circle is 154 centimeter square. So the concept was, when the wire, the length of the wire is fixed, it is not changing. So when the wire was in the shape of a square, we know the whose area is given, the area of the square is given. From the area of a square, we can easily find the length of each side of the square, and from the length of each side of a square we can find its perimeter. So once the perimeter of the square is known, we know that the length of the wire is equal to perimeter of the square. So, and the length of the wire will also be equal to the circumference of the circle. So we will know the circumference of the circle, and from circumference of a circle we can find its area. Okay, let's see question number 10. A wire is in a circular shape of radius 28 centimeter. If it is bent in the form of a square, what will be the area of the square formed? So this time it is the other way around. Initially the wire is in the form of a circular shape having radius, let's say small r, and then it is rebent to form a square. Let's say the length of the square is x. Okay, so the area of the circle is given. No, the radius of the circle is given. So r, when the wire was initially in the shape of the circle, the radius of the circle is given to be 28 centimeter. So what will be the length of the wire? The length of the wire will be equal to length of wire is equal to the circumference of the circle, which is equal to 2 pi r. Okay, 2 pi r. R we know, small r, we know as 28 centimeter. Okay, now so the circumference of the circle will be equal to the perimeter of the square. Now if we consider the side length of the square to be x, the perimeter for the square will be 4x. So now we can say the perimeter of the square will be equal to the circumference of the circle. So we can say 4x is equal to 2 pi r. Remember that small r is known, we know. So this implies x is equal to 2 pi r divided by 4, which is pi r by 2. Okay, so now what will be the area of the square? The problem has asked the area of the square. So area of square is x square, which is equal to pi r by 2 square, which is equal to pi square r square by 4. This is equal to 22 by 7 multiplied by 22 by 7 multiplied by r square. R is 28. 28 multiplied by 28, and then we have divided by 4. This much centimeter square. Okay, let's simplify. 4 divides 28 with 7, 7 cancel out, 7 divides 28 with 4. So this is 88 multiplied by 22 centimeter square, which is equal to 176, 6391. So this should be 1936 centimeter square. Okay, let's do the next problem. Question number 11. A rectangular sheet of acrylic is 34 centimeter by 24 centimeter. From it, 64 circular buttons, each of diameter 3.5 centimeter, have been cut out. Find the area of the remaining sheet. Okay, so we have so the area of the remaining sheet will be the area of the rectangular minus the area of the 64 circular buttons. Okay, so let's see what is the area. First, let's see. So area of sheet which is in the form of rectangle. Area of the sheet is equal to the area of the rectangle whose dimensions are 34 centimeter and 24 centimeter. So it will be 34 multiplied by 24, this much centimeter square, which is equal to, I am using the calculator, 34 multiplied by 24 is 34 multiplied by 24 is 816. So this is 816 centimeter square. And what is the area of each button of each circular button will be pi r square, the radius square. The radius of the circular button is given to be, the diameter is given to be 3.5. We know that area is equal to pi d square by 4. So area d square by 4. This is equal to 22. So this is equal to 1 by 4 multiplied by pi, which is 22 by 7, multiplied by d square. D square, the diameter of each circular button is given to be 3.5. So 3.5 multiplied by 3.5. This much centimeter square is the area of each circular button, which is equal to, we have 22. Let's convert the decimal 3.5 as fraction. So we have 22 multiplied by 35 multiplied by 35 divided by 4 multiplied by 7 divided by 100, because 3.5 is 35 by 10, and again 3.5 is 35 by 10. So this now is okay. 64. Okay, so this is the area of each circular button, and there are how many circular buttons are cut out? 64. So this implies area of 64 buttons is equal to 64 multiplied by 22 multiplied by 35 multiplied by 35 divided by 4 multiplied by 7 multiplied by 100. This much centimeter square. Okay, so 4 divides 64 with 16. Okay, 7 divides with 5, and 5, 20, 10, 11. So this is equal to 16 multiplied by 11 multiplied by 35 divided by 10, this much centimeter square. What will be 16 multiplied by 11 multiplied by 35 is 6160. So this is 6160 by 10 centimeter square, which is equal to 616 centimeter square. So this is the area of 64 buttons. So this implies the question has asked find the area of the remaining sheet. So area of remaining sheet will be equal to the area of the rectangle, that is the original whole sheet, which was 816 minus the area of 64 circular buttons, which is 616, this much centimeter square, and this is equal to 0 or 200 centimeter square. It will be the area of the remaining sheet. Okay, let's see the next problem, question number 12. A rectangular ground is 90 meter long and 32 meter broad. In the middle of the ground there is a circular tank of radius 14 meter. Find the cost of turfing the remaining portion at the rate of rupees 50 per meter square. So we have to find the area of the remaining portion. So there is a rectangular field, and in the middle there is a circular tank of radius 14 meter. Okay. Okay. So let's say, so what is the area? Let's say area, let it be A1. Area of a ground, that is the rectangular ground, is equal to length multiplied by breadth, that is 90 multiplied by 32, this much meter square. This is equal to 2880 meter square. Okay, so this is the area of the entire rectangular ground. And what is the area of the tank? Let's say that be A2. So area of tank, which is circular, is equal to pi r square, and this is 22 by 7, and the radius of the tank is given to be 14 meter. So this is 14 multiplied by 14, this much meter square. This is equal to 2, so 44 multiplied by 14 meter square, which is equal to 56 and 56. So 616 meter square is the area of the circular tank. So this implies area of remaining portion will be equal to A1 minus A2, which is equal to 2880 minus 616, this much meter square, which is equal to 2264 meter square is the area of the remaining portion. And the question is asking find the cost of turfing the remaining portion at the rate of rupees 50 per meter square. So this implies we have to turf a total area of 2264 meter square, where the rate is rupees 50 per meter square. So a cost of turfing, I don't know what does turfing mean. Means cost of turfing will be rupees, rate is 50, and the area to be turf is 2264, this much rupees. This is equal to how much is 2264 multiplied by 5, it is 11320. So this is rupees 11320. Okay. Question number 13. So we have a figure. 4 equal circles are described about the 4 corners of a square. So there is a square. At each corner 4 circles are drawn so that each circle touches 2 of the circles as shown in the figure. Find the area of the shaded region where each side of the square is 14 centimeter. So we have a square. Let's say this is a square approximately. This is a square. So at the 4 corners, these are the 4 corners. These 4 corners, 4 circles are drawn so that one circle is touching 2 other like this. So this is a circle, and it will touch the circle drawn at this corner like this. My figure will be very approximate. I hope you will get the idea. Okay. Now, so each side of the square is given to be 14 centimeter. 14 centimeter. Now the concept is that these 2 radius, let's say there are 4 circles. There are 4 circles at 4 corners. Let's name the circles A, B, C, D. Just for the sake of discussion, I am naming the circles A, B, C, D. No, not A, B, C, D, because the square is given as A, B, C, D. So the square is given as A, B, C, D. Now this point where the 2 circles, that is the circle which is centered at the point at the vertex D, and the circle which is centered at the point C, these 2 circles, let's say, are touching at the point, let's say, E. Similarly, let's say the 2 circles centered at the point D and A, they are touching at the point F, and the circles centered at the corners A and B, they will touch at the point G, and finally the circles which are centered at the vertex C and B, let's say, they are touching at the point H. Now the concept is that we will have the point E at which the 2 circles are touching, that will be the midpoint of DC. That is, DE will be equal to EC, and DF will be equal to FA. Similarly, AG will be equal to GB, and CH will be equal to HB. Now, what are DE, EC, DF, FA, CH, HB? These are all. Now, since you will notice that all the 4 circles will be of same size, that is, the radius will be same. So if you consider, so these all will be, let's say, R. Let's say these are all R, small r, and where this small r is the radius of all the 4 circles. We have to find the area of this area, shaded region. What is this shaded region? This we can find this shaded region if we subtract. Now let's see that inside what is this shaded region. This is nothing but the entire square minus at the 4 corners. We are having a sector of the circles. We are having 4 sectors of the circles at the 4 corners. By sector I mean this part. So this is a sector. This is all the circles at the 4 corners. They are of equal size, that is, they are of same radius. Now this is a sector. This is a sector where the angle FDE FDE is equal to 90 degree. So please note that I have already discussed what is a sector. A sector is, so if we have a circle, and then there is an arc, let's say A and B are the endpoints of an arc, and the arc is making an angle theta, then this entire region is a sector, and this sector is said to have a central angle. This angle theta is known as the central angle, that is the arc AB, or the sector is having and a central angle of theta and of a circle of radius r. So to define a sector we need two things. One is the radius of the circle, and what is the central angle it is making, that is theta. Now if this theta becomes 90 degree, then the sector, if this theta becomes 90 degree, let's say let's consider another sector. This is 90 degree. Let's say the endpoints are C and D. Now this sector is known as a quadrant of a circle, because this the area of this sector will be one fourth the total area of the circle, since this sector is making an angle of 90 degree. So why the area of this sector will be one fourth of the area of the circle? Because we know that the area of a sector we know is theta by 360 multiplied by pi r square, where r is the radius of the circle. So if theta is 90, so if theta is 90, you can see 90 by 360 is 1 by 4. So pi r squared by 4. So the area of a sector which is making a central angle of 90 degree is always 1/4 the area of the circle having radius r. So in this figure, at all the four corners we are having sectors which are making and all the sectors are having a central angle, that is theta is 90 degree. So the area of the sectors, there are four sectors, so the area of all the four sectors will be 1/4 the area of each of the circles. All the circles are of same area or same size, since their radius is same, which is r. And what is r? R is nothing. Now what is r? R is nothing but the side length, half the side length of the square, that is 14 by 2 centimeter, which is 7 centimeter. Since the side length of the square is given to be 14 centimeter, half of it is 7 centimeter, and the radius, so the radius of all the circles at all the four corners, they are same, and it will be 7 centimeter. Okay. And since all the sectors at the four corners, they are having a central angle, that is a theta is equal to 90 degree. So their area will be equal to 1/4 the area of all the circles. Okay. So area and since there are four such sectors, so the area of all the four sectors will be equal to the area of each circle. So area of each sector at a corner is equal to pi r square by 4, where r is the radius of all the circles at all the four corners. Okay. So this implies, since there are four sectors, area of four such sectors will be equal to 4 multiplied by pi r square by 4, which is eventually pi r square. So all these four sectors, if you sum them up, it will become a whole circle. So the area of all the four sectors at the four corners of the square is pi r square, where r is we have found to be 7 centimeter. So this is equal to pi r square. Now pi is 22 by 7 and r we have found to be 7. So 7 into 7, this much centimeter square, and which is equal to 154 centimeter square. So, and 154 centimeter square is also the area of each circle at one corner of the square. Okay. So what will be the area of the shaded region as given in the problem? So area, this implies area of shaded region will be the area of the square, which is 14 multiplied by 14 minus the area of all the four sectors at the four corners, which sum up to be the area of each circle at every corner, which is equal to 154. So 154, this much centimeter square. 14 multiplied by 14 is 196. 196 minus 154 centimeter square, which is equal to 42 centimeter square is the area of the shaded region. So the concept was that since the circles are touching each other, since the circle centered at the vertex centered at the vertices C and D, they are touching. This will mean that their radius will be same. Their radius will be same, and the radius will be equal to half the length of the side of the square. Okay, let's see the next problem. Question number 14. A horse is tethered to one corner of a rectangular field, 60 meter by 40 meter. So the dimension of the rectangular field is 60 meter length, 60 centimeter length, not centimeter, it will be meter. I have incorrectly in the figure I have incorrectly written 60 centimeter, but it will be 60 meter. So the length of the rectangular field is 60 meter and the breadth is 40 meter. Okay, and there is a horse is tethered to one corner of a rectangular field. Okay, by a rope 14 meter long. So basically, as per the given figure, so this is the rectangular field. Let's say ABCD is the rectangular field, and the horse is tied at the corner A, and by a rope 14 meter long. So let's say this be let's say AE be the rope. So this length of the rectangular field is 60 meter and the breadth is 40 meter, and the rope by which the horse is tethered is AE. This is 14 meter. This is 14 meter. Okay. On how much area can the horse graze? On how much area can the horse graze? Now remember that the field is rectangular field. The horse will never go outside the rectangular field. It has to remain inside the rectangular field because the horse will only graze over the field. So definitely the area that the horse can graze is nothing but, if you consider a circle, it will be a sector. It will be the sector. So if you consider AE is the string, it will be the area, the maximum area on which the horse can graze will be this sector. Where this sector is part of a circle whose radius is AE, that is the length of the rope, and definitely this this sector is making, so this will be, A will be the center of the circle, and the sector, that is, let's say this be F, this be f. So the arc FE is making an angle 90 degree with the at the center of the circle. So the area on how much the horse can take the horse can graze is nothing but the sector AFE. So we have to find the area of the sector AFE. So how can we find the area of the sector AFE? So AFE, if you see AFE, the sector AFE is part of the circle whose radius R will be equal to the length of the rope by which the horse is tied, AE, which is equal to 14 meter. And this is, so let's say this point is F and this point is E, and let's say this is the point, let's say this is the vertex A of the rectangle, that, which will be also the center of the circle. And not here, F will be here, F will be here, F will be here. So this is 90 degree. So obviously this area, this is the area of the sector, this is the area on which the horse can graze. So we have to find the area of the sector. Okay. Now when and you can see that the sector is making an angle of 90 degree at the center of the circle. So the area of sector, let's say sector AFE, we know that if a sector makes an angle of 90 degree at the center, that is the central angle of a sector is 90 degree, then its area will be equal to 1/4 the area of the whole circle. So the area of the sector AFE will be pi r square is the area of this whole circle by 4. Okay. So this should be equal to 22 by 4 multiplied by r is 14. So 14 multiplied by 14, this much meter square. Okay. So this is 211 to 7. So this is 77 multiplied by 14. Now, how much area can the horse graze? Why it is 154 meter square? A horse is tethered to one corner of a rectangular field, okay, 60 meter by 40 meter, okay, by a rope 14 meter long, On how much area can the horse graze? On how much area can the horse graze? So it should be 1/4 the area of a circle whose radius is 14 meter. Pi r square by 4, I did it wrong, sorry. Pi r square by 4, that is fine. Now this is equal to pi, so this is 1/4 multiplied by pi is 22 by 7, and r will be the radius of the circle, which is nothing but the length of the rope by which the horse is tied. So this is 14 multiplied by 14, this much meter square. This is equal to 211 777. So this is 11 multiplied by 14 meter square, and this is equal to 14 and 14, so 154 meter square. So 154 meter square is the area on which the horse can graze. Okay, let's see the next problem, question number 15. a circle of diameter 21 centimeter is given. Inside the circle, two circles with diameters 2 by 3 and 1/3 of the diameter of the big circle have been drawn. Find the area of the shaded region. Okay, so there is a big circle, and there is a inside the circle. So this inside the circle, the bigger circle is touching the. So this circle, please note that this circle, whose radius is 2/3, whose diameter is 2/3 the diameter of the the outer bigger circle, it touches the circle. And there is another circle. There is another circle. Even though the two circles are looking same, let me. So this is one circle. So this is the inside bigger circle, and this is touching the outer bigger circle. We have one smaller circle touching this. Okay, I hope you are getting the idea. So these two circles, let's say the circle, the circle inside the bigger circle, whose diameter is 2/3 the diameter of the bigger circle, let its center be C. Let's say its center be A, and the center of the inside smaller circle be B. Please note that since these two circles, the two circles inside the bigger circles, they are touching each other, that means that if you join the center of the two inner circles, they will pass through the point where the two inner circles are touching. That is, if the two inner circles are touching at the point E, AEB will be a line segment. That is, AEB, the points A, E and B will be collinear. They will be in a straight line. And also notice that so AE, what is AE? AE is, let's say AE is the radius. AE is the radius of the inner bigger circle. Let's say this be R1, and let's say so this is R1, and let's say this the radius of the inner smaller circle be R2. That is AE. E is the point at which the two inner circles are touching each other, and so E, the points E at the center of the two circles, which are A and B, they will lie on the same straight line. So we will have AE. We are considering AE is the radius of the inner bigger circle. Let that be R1, and EB is the radius of the inner smaller circle. Let that be R2. Now, okay. Now, okay. So, what is given? The diameters of the two circles are given to be 2/3 and 1/3 of the diameter of the big circle. Okay. So find the area of the shaded region. But what is the bigger circle? The outside bigger circle is having a diameter of 21 centimeter. Okay. So obviously the area of the shaded region, which is this area, this is the area, this is the shaded region whose area we have to find. Now this shaded region, its area is nothing but the area of the outer bigger circle minus the area of the inner two circles. Okay, so let's say the outer bigger, okay, also know, one second. So what will be, let's say, let R be not R, since the diameter of the outer bigger circle is given, and also the diameter of the inner two circles are given as the ratio of the diameter of the outer bigger circle. Let's consider we will find the area of the outer bigger circle and the two inner circles in terms of their diameter. So let's say let D be diameter of outer bigger circle, outer not bigger, let's say outer circle. Okay, so area of outer circle, we know the area of a circle in terms of diameter is pi diameter square by 4. So this will be pi d square by 4. Okay, and area, similarly area, let's say, okay, again, so area of circle at area of circle centered, let's say centered at A will be equal to pi, let's say, let the diameter of the inner bigger circle B, let the diameter of the circle centered at A be d1. So the area of circle centered at A will be d1 pi d1 square by 4. Similarly, area of circle centered at B will be, if we consider the area, the diameter of the circle, inner circle centered at B to be d2, it will be pi d2 square by 4. Okay. We also know that d1, we know that d1 is equal to 2/3 d, and we know d2 is equal to 1/3 d. Okay. Okay. So what is so area of total area of two inner circles will be equal to pi d1 square by 4 plus pi d2 square by 4. This is equal to, if I take pi by 4 common, I have pi by 4 and then d1 square plus d2 square. Okay, this is equal to pi by 4. What is d1? D1 is 2 by 3 capital D. So d1 square will be 2 by 3 capital D, this square, plus, and d2 was 1 by 3 d, this square. So this is equal to pi by 4, and we have 2 by 3 d, square of 2 by 3rd of d is 4 by 9 d square, and we have d by 3 square, square of d by 3 is d square by 9. Okay. This is equal to pi by 4, 4 by 9 d square plus t square by 9 is 5 by 9 d square. Okay. So this is the area, total area of the two inner circles, and the area of the bigger circle, outer circle, is pi d square by 4. So what will be the what will be the area of shaded region? Area of shaded region will be equal to the area of the bigger circle, which is pi d square by 4, minus the area of the two inner circles, which is pi by 4 multiplied by 5 by 9 d square. From here, if I take pi d square by 4 common, this will be 1 minus 5 by 9. This is equal to pi d square by 4. 1 minus 5 by 9 is 4 by 9. 4 by 9. So this is equal to pi d square by 9. Okay, and we know d is the diameter of the bigger circle, which is given as 21. So this is now 20. So this is 1 by 9 multiplied multiplied by pi. Pi is 22 by 7 multiplied by d. D is 21 multiplied by 21. So this much centimeter square is the area of the shaded region. Now this is equal to 3 and 337, which is equal to 154 centimeter square. Okay. So the last question, question number 16. ABCD is a rectangular plot of field that measures 8 meter by 6 meter. Okay. So we have a rectangular plot. ABCD, A, B, C, D. Okay. 8 meter. So this is 8 meter, and this is 6 meter. Okay. In each of the corners there is a flower bed in the form of a quadrant. Now remember, a quadrant of a circle. A quadrant of a circle means a sector of a circle who's making an angle of 90 degree at the center. That is, if you have a circle, so so a quadrant is nothing but a sector that makes 90 degree. This is the center O. It will make 90 degree at the center. This is the arc of the sector. So this is 90 degree. So the endpoints of the arc AB is making a sector whose angle at the center is 90 degree. Such a sector is known as quadrant of a circle, and this sector AOB, since it is making an angle of 90 degree at the center, which is known as the central angle, its area will be equal to 1/4 the entire circle. Okay. So at every corner we are having a flower bed, a circular flower bed in the form of a quadrant of a circle of radius 2 meter. Okay. So this corner considered, so this length is 2 meter, this length is 2 meter. Okay. So here we will have this sector, so this will also be 2 meter. Okay. So we know that the area of this sector, let's say this be point E and F. So the area of the sector DEF will be 1/4 the area of the circle having 2 meter as diameter. Okay, fine. So this kind of sector is there at every corner. At every corner of the rectangle. Okay. Now again, since there are 4 such sectors at 4 corners of rectangle, if you sum all the area of all the sectors, that is the quadrant of a circle at the 4 corners, their total area will be the area of a circle having a radius of 2 meter. Okay. And also there is a flower bed in the form of a circle of radius 2 meter in the middle of the plot. Okay, so there is a circle, there is a flower bed, circular flower bed of radius 2 meter at the center of the plot. Okay. Find the area of the remaining plot. Okay, so we have to find the area of the remaining plot, means this area we have to find. I am trying to shade the region whose area we have to find. So this region, the area of this region we have to find, which is nothing but the area of the rectangle minus the area of the central circle and the area of the four sectors at the 4 corners. Now the area of the 4 sectors, the area, let's say names S1, S2, I am naming the sector as S1, S2, S3 and S4. and S4. So area, okay, so area of S1 will be equal to area of S2. The area of all the sectors will be equal because they are sector of a circle having the radius 2 meter, and they are making an angle of 90 degree at the center. That is, they are quadrant of a circle. Each of the sectors at the four corners of the rectangle are quadrant of a circle with 2 meter radius, which means that each sector, the area of each sector will be 1/4 the area of a circle of 2 meter radius. S3 is equal to area of S4. This will be equal to 1/4 the area of a circle with 2 meter as radius. Okay, this much meter square. So this implies definitely area of S1 plus area of S2 plus area of S3 plus area of S4 will be equal to 4 times multiplied by 1 by 4 multiplied by pi multiplied by 2 square, this much meter square, which is equal to basically area of a square of radius 2 meter. This is equal to okay, let it be. So this is equal to 4 pi meter square. Okay. Now what is the area? Let's say the circular flower bed be S. I am denoting the circle at the center by S. So area of S is nothing but its radius is 2 meter. So that is this meter square, which is equal to 4 pi meter square. So this implies area of the question was find the area of the remaining plot. So area of remaining plot will be equal to area of the rectangle ABCD minus the area of all the 4 quadrants at the 4 corners, which is equal to area of S1 plus area of S2 plus area of S3 plus area of S4, which is 4 pi, and again minus the area of the circular flower bed at the center, which is also 4 pi. This much meter square. Now what is the area of the rectangle ABCD? It is 8 into 6. 8 into 6 minus 4 pi is 8 pi. Okay. So this is equal to 48 minus 8 pi. This is equal to 48 minus 8 pi is 22 by 7. So this much meter square. Okay. So this is 48 multiplied by 7 minus 22 multiplied by 8 is 176. This much 7 meter square. 48 multiplied by 7 is 56, 28, 33. 336 minus 176 by 7 meter square, which is equal to 0, 6 to 1, 160 by 7 meter square. So how much is 160 by 7? 160 divided by 7 is 22.85. So this is equal to 22.85 meter square. So with this, it comes to an end in solving the problems of exercise 20F. These problems were based on the area and circumference of a circle. And the problems related to finding the area of shaded region or finding the area of the remaining plot, these are a little conceptual. You must be solving this kind of problems a lot to have clarity of the concept. I will try to come up with more this kind of problems so that you will have a good practice. Now, before solving the problems of the next exercise, that is 20, so this was exercise 20F. So before solving the problems of exercise 20G, which is objective questions, I will try to come up with more example problems on finding the area of shaded region, or this kind of problem that has figures and that has circles inside at the corners of a rectangle or inside a rectangle or quadrants. So this kind of problems which are based on figures and quadrants or sectors and circles inside a square or rectangle, you should practice this kind of problem a lot to have so that you can solve them easily. Okay, so if this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So the next video, I will come up with solving a few more example problems based on finding the area of shaded region based on circles and rectangles and squares, or even circles inside another circles, before moving on to solving the problems of exercise 20G. So these videos are coming soon, so please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.